In this video, we are going to talk about parallel and perpendicular lines. So two lines that do not intersect and have the same slope are called parallel lines. So here we can see they have the question, are the lines y equals minus 2x plus 3 halves and y equals minus 2x plus 3 parallel? So what we'll need to do is determine the slope of each of these lines. So if you look at the first line, y equals minus 2x plus 3 halves, right? This line is written in the slope-intercept form, right? Y equals mx plus b. And same thing with the other line, right? They are written in that form exactly. Y equals mx plus b. And so it's very easy to tell the slope of a line that's written in this format because it's the number with the x, right? So the slope of this line is negative 2. And looking at this other line over here, the slope is also negative 2, right? Because it's written in the slope-intercept form, and that is the number with x. So these two lines have exactly the same slope. So therefore they are parallel. Okay. So that's pretty straightforward. As if both of the lines are in y-intercept or slope-intercept form, then it's really easy to tell if they're parallel or not. If one of them is not in slope-intercept form, then you would just do the work like we had shown in previous videos about how to put the lines in y-intercept form. If you graph these out, you can see on Desmos. Here's y equals minus 2x plus 3 halves. And the line y equals minus 2x plus 3. And you can see those are parallel lines. They do not intersect each other. Okay. So in this example, what we want to do is find the equation of the line through the point 1, 4 that is parallel to the line 2x minus 4y equals 3. Okay. All right. So through 1, 4 parallel to 2x minus 4y equals 3. All right, so here's the point 1, 4, and the line is 2x minus 4y equals 3, okay? So we want to find a line that goes through this green point, right, that is parallel to this line right here. Okay. So what we're going to do is start with the point slope form of a line. The point slope form of a line is y minus y1 equals m times x minus x1. Okay, so, and that is for a point x1, y1 that's on the line and where m is the slope, right? So we are given a point on the line. They tell us that the point 1, 4 is on the line. So you can use this as x1, y1, all right? So again, this in pictures, right, it's this green point. Our line goes, the line that we're looking for, the line whose equation we're looking for, goes through this green point. And so we know that 1, 4 will be a point on the line. So that gets us part way to an equation. We can take the 1 and put it in for x1. We can take the 4 and put it in for y1. And all that leaves us to do is the slope here. Okay? So to get the slope, right, they tell us that the line whose equation we're looking for is parallel to this line right here. And so what we need to do is to find out what is the slope of this line. So what is the slope of that line there? Well, if this line were in the y equals mx plus b, the slope-intercept form, then we could just read it off. But unfortunately, it is not. Okay, but it is not all that difficult to figure out how to put it into slope-intercept form, right? And that is what we need to do is put this in slope-intercept form. We need to solve, so that means solve for y. All right. So to solve for y, we would subtract 2x from both sides and get all the y's by themselves on one side. Okay, so subtract 2x from both sides. And then we would divide each term by -4. So remember that trick I showed you previously, right, about dividing through by each term, right, rather than both sides. So here, -4 divided by -4 is a +1, which I'm not going to bother to write. -2 divided by a -4 is -2/4, and we will have to reduce this. 3 divided by a -4 is -3/4, so which I just wrote as -3/4, right? Because that's the same. Adding a -3/4 is the same as subtracting a 3/4. Next up, I can reduce this, right, fraction, because there's a common factor in the top and the bottom of -2, right? So -2 goes into -2 once, -2 goes into -4 2 times. All right. So there, I have now put this line in slope-intercept form. Okay. So now I can easily read off what the slope is. The slope of this line is +1/2. All right, so now it's no longer a question up here. I know that the slope of the line 2x minus 4y equals 3 is +1/2. Okay, so since this line that I'm looking, whose equation I'm looking for, is parallel to this line, that means that this line's slope must also be 1/2, right? Because of the fact that parallel lines have the same slope. So now I have a point that was given to me, 1, 4 on this line, and now I have this line's slope, which is 1/2. All right, and so now I just need to put this in y equals mx plus b slope-intercept form. It didn't really say to do that, I don't think. Let's see. Yeah, it says find an equation of the line through the point, but probably on most of the Newton problems that you'll be doing, they probably are going to ask you to put it in slope-intercept form. This is one that has a fraction in here, so in previous videos I said, hey, you can just multiply both sides of the equation by the LCD, right, which is 2, and that will clear out the fractions. We only have one fraction in here, 1/2, and the denominator is 2, so the least common denominator of the LCD will be 2, right? And then we can go ahead and solve for y. So on this right side, I would distribute the 2 through the parentheses. 2 times 1y is 2y. 2 times 4 is 8, so that would be minus 8. 2 times a half is a positive 1, right? And then 1 times x minus 1 would be just x minus 1, right? If there's no number out in front, or 1, it's a 1 out in front, you can just get rid of the parentheses. So that's what that would look like. So now all the fractions are gone, and again, I just want to solve for y just like I did over here, right? I would add 8 to both sides. I get 2y equals x. Negative 1 plus 8 will be a positive 7. And then divide each term by 2. So you get y equals x over 2 plus 7 halves. You might also see that written as 1/2 x plus 7 halves, right? This is like a 1 right here, and then you can pull that apart just like I showed you in a previous video. All right, so this is the answer that we're looking for. Y equals 1/2 x plus 7 halves. Let's take a look right in our graph, and we will graph out our answer, which is y equals 1/2 x, oops, not that, 1/2 x plus 7 halves. And it should go right through that green point, and it should be parallel, right, to this line right here, which it is. Okay. Okay, so that is how to find an equation of a line through a point that's given to you and that's parallel to a line that's given to you. All right, next up are perpendicular lines. So 2 lines that intersect at right angles are called perpendicular lines. So if M1 and M2 are the slopes of 2 lines, neither of which is vertical, a vertical line, then the lines are perpendicular if and only if M1 times M2 is negative 1. So in other words, 2 lines that are perpendicular, 2 lines that intersect at a right angle, right? If you take their slopes and multiply them together, you would get a negative 1. Okay. Another way that you'll hear people say that is that the 2 slopes are negative reciprocals of each other. All right. If we're talking about horizontal lines and vertical lines, right, then vertical lines don't have slopes, so you can't really say that this is true. But the situation is any horizontal line is perpendicular to any vertical line, right? And vice versa as well. All right, so in this slide I have a question for you, and it says, is the line y equals 1/2 x plus 3 halves, is that perpendicular to the line y equals minus 1/2 x plus 3 halves? Okay, so that's the question. Are these 2 lines perpendicular? Okay, so first off, what you would do is find the slope of each one of these lines. The slope of this line, right, this is written in the y equals mx plus b format, right, the slope intercept format. Right, and so if it's written in this, if you have a line that's written in the slope intercept form, then you can just read the slope right off from the formula, because it will be the number with x if it's written exactly like this. So the slope of this line is positive 1/2. All right, And then the slope of this line, same thing for it, right? We can just read it right off because it's in the slope intercept form. That is going to have a slope of -1/2. All right, so we have both of the slopes. To see if these lines are perpendicular, what we would do is multiply these together. So 1/2 times -1/2. All right, so that's going to be a negative, right? Negative number because a positive times a negative is a negative. And then we're multiplying fractions. So 1 times 1 is 1. And 2 times 2 is 4, right? So when we multiply the two slopes, we get -1/4, which is not equal to -1, right? So the two lines are not perpendicular. Okay. All right. So if we had, say, now, imagine if we had this line y equals 1/2 x plus 3/2, and we had y equals -2x plus 1, right? Then the slope of this would be 1/2, the slope of this line. The slope of this line would be -2. And so when we multiply that together, we get -2/2, which is -1. So these two lines would be perpendicular, okay? Because when I take their slopes and multiply them, I get a, oops, that should be a -1. Sorry, -1. So when I multiply these two slopes together, I get a -1. If I go graph these lines out, 1/2 x plus 3/2, and the other is y equals -2x plus 1. All right, if you have a correct viewing window, you can see that these intersect, and it looks possible that that might be a right angle, right? Okay. Now, when you are looking on some technology and graphing this out, it's pretty easy to tell no matter what the two lines are parallel, because they're going to look parallel kind of no matter what. But it's not true with perpendicular lines. If your graphing window is not, say, like perfectly square, so if this was like 99 or something like that, and you graphed it out, then that doesn't look like a 90-degree angle at all, does it? Right? And so that it's like the perspective of it. If you're looking at from kind of a weird angle, or this window is distorted, it's not going to look right. So if you're sketching these out to check yourself and stuff, you have to be aware of that. If you don't have the perfect like square viewing window, it's not going to look right, okay, for perpendicular lines. All right, let's do one more example like this. So here we want to find an equation of a line that goes through the point -1, 3, and is perpendicular to 2x plus 4y equals -1. Okay. Okay, so again, what we want to do, we're looking for the equation of a line, right? We can start with the point slope form. In the point slope form, all we need is a point that's on the line, and we're already given that, right? We're given that this point -1, 3 is on the line. So this would be x1 and y1, the point that we're given, and we can just plug those numbers in. So we would plug in 3 for y1 and x1 is a negative 1. So that would be x minus a negative 1. Okay. So now all we need to do to complete this problem is figure out what the slope of this line would be. So they tell us that it is perpendicular to this line, 2x plus 4y equals minus 1. So what we would need to do is to find the slope of this line right here. So what is the slope of this line? In order to do that, we would need to put this in slope-intercept format, right? So solve for y. So subtract 2x from both sides. So I get 4y equals minus 2x minus 1. And then divide each term by 4. So we get y equals negative 1/2 x minus 1/4. Okay. So here, right, I cancel these out, and then I reduce this. Negative 2 over 4 will come out to be negative 1/2. So now I know that the slope of this line is negative 1/2. By the way, this upside down t sign is perpendicular, the sign for perpendicular, if you're unfamiliar with that. So I forgot to mention that earlier. Okay, so the slope of this line is negative 1/2, right? So what you're going to have to do, right, is the slope of the line that we're looking for, the one that's perpendicular, what you would do is flip this over. So it would be minus 2 over 1, and then take the opposite of it. So that would be the reciprocal, right? The reciprocal is just a fancy word for saying flip this over. And then the negative, right, means take the opposite of it, multiply it by negative 1, or however you want to look at that. So if this line's slope is negative 1/2, right, you would take the negative reciprocal, flip it over, and take the opposite sign. So that's going to be negative of a negative 2, which would be a positive 2. All right, so a line that's perpendicular, this one will have a slope of 2. That goes over in for the slope in our other line over here. So the slope of that line is 2. All right, and then we will just simplify this as much as possible. So we would need to simplify both sides as much as possible. Before I distribute that 2 through the parentheses, I'm going to add the opposite here, right? X minus a negative 1 is the same as subtracting a negative 1 is the same as adding a positive. So x minus a negative 1 is the same as x plus 1. Then I can distribute that 2 through the parentheses. So I get 2x plus 2. And then add 3 to both sides to solve for y. I'll get y equals 2x plus 5. Okay, so if I graph this point out, just double checking, minus 1 and 3. Right, that's the point that we had. So 2x plus 5, right? Should go, well, actually, let's graph this line. So we had this line, 2x plus 4y equals minus 1. All right, so our line should go right through this blue point and then look like it's making a 90-degree angle with the green line. So y equals 2x plus 5, okay? And so here we have a nice square graphing window, right? We can tell by looking at these areas that are centered around here. It looks like a nice square, right? And In other words, it goes from -2 to 2 and -2 to 2 here. Right? And so you can see it looks perfect. It goes to the blue point and it looks like a rectangle here. But remember, don't think, again, if these things are not square, right? If it looks like that, you see how this is -2 to 2, and that's the scale is totally different on this, right? It doesn't look perpendicular at all. So you got to keep in mind, you can't always trust what the graphing window is showing you in regard to being perpendicular. But here you can see it looks perfect because you have a nice square window, same scale on both axes. Okay. All right, so that's how to deal with parallel and perpendicular lines.